In addition to factoring polynomials down to a product of two binomials, we may also have to solve that set of factors and set it equal to 0. This involves what's known as the zero product property. If two numbers are multiplied together and the product is 0, that means one of the numbers must also be 0. In this case, we have to allow for each of them to equal 0. So what I like to do here is just draw a vertical line and set each of the binomial factors equal to 0. And then simply solve these equations. Noting that for this product of two binomial factors, there are two values that would allow for the product of them to equal 0. If x equaled positive 1, then 1 minus 1 is 0, and 0 times whatever this factor is would equal 0. And if x equaled negative 4 plus 4 equals 0, so 0 times whatever this factor is would also equal 0. Many students will note that we're really looking at the opposite of the value of what's in here. So if we're minus 1 and our coefficient on x is 1, then this will be the opposite of that, a positive 1. If we are positive 4 here, then the inverse of that, negative 4, would be the value for x here. But that's not always the case, especially when you have coefficients that are not 1. So likewise, we have two binomial factors here that have a product of 0, so we have to assume that one or both of them could equal 0. So we draw a vertical line and set each factor equal to 0. And then solve the equation. This time, instead of being a one-step equation, you have a two-step equation. We're always going to start by undoing the addition or subtraction first, working in reverse order of operations order, and then we'll undo any division after that. So x in this case would equal positive 2/7. And now we'll solve this equation the same way. We'll undo the addition by subtracting. So 3x equals negative 1. And then we'll undo the multiplication by dividing. So x would equal negative 1/3. So x could equal positive 2/7, in which case this factor would equal 0, and times whatever this factor is would result in the product of 0. Or x could equal negative 1/3. When x is negative 1/3 here, this term equals negative 1 plus this one equals 0, which when multiplied by whatever this factor is would also equal 0.